Hi, good morning, everybody. This is Mrs. Baxter, and today we are going to be talking about conversions. So we're going to take those fractions, convert them to decimals, convert them to percentages. We're going to convert things back to fractions and back to decimals and back to percentages. So this is a very good life skill to have, especially when you're looking at say sales or percent off or things like that you want to figure these things out pretty quickly in your head or get really close to it. Okay. So the first thing we're going to do is we're going to do a little bit of a warm up, and then we're going to move through some things with calculators and without calculators. Okay, so I want you to try these without calculators because guess what? On the quiz, you are going to have to do some of these things without a calculator. Okay. All right, so the very first thing we're going to do is we're going to do a quick warm-up, multiplication by hand, no calculator. So pause the video, see if you can solve these two problems either on a scratch piece of paper or on your notes, and then come back here and check in and make sure that you were able to complete these properly. Okay, so hopefully you were able to complete these without a calculator. I'm going to really quick do something here. Okay, and then I apologize too because I'm at home doing this, and if Lucy and Leo start barking, I might have to go shush them up, or you'll just have to hear them barking and talking to our neighbors as they walk by. All right, so let's do this. 27 times 5. Don't forget 7 times 5 and then 2 times 5. That's what order we're going to go. 7 times 5 is 35. Since this is the ones column, I'm only going to put the answer to my ones here. So 35 goes here. This is my tens column, right? So I'm going to put my 3 here. But first I'm going to multiply 2 times 5 and I'm going to get 10. But I need to add those 3 more 10s in, which is 13. So my answer is 135. So hopefully you got that as your answer. All right, this one's a little bit more complicated. I'm going to do it over on the side here because I need a little more room. But I'm going to go 61, and I like to put my big number on top. Makes it a little bit easier to organize. And I'm going to do the same thing, okay? So I'm going to start with my ones column, and I'm going to say 1 times 2 is 2, 1 times 7 is 7, 1 times 8 is 8. Now, it's really important to keep your ones, tens, and hundreds lined up as we do this, okay? All right, so now I've got my ones done, 1 times 2, and interestingly enough, notice that 1 times 872, it equals 872. Now we're going to go and look at what's 6 times 872, okay? But because we're starting in our tens column, we have to put a 0 down here because we don't have any ones, all right? We're doing 6 tens times 2, which is equal to 12. So then I'm going to carry my 1. 6 times 7 is 42, so now I'm going to put 43. I'm going to carry my ones, actually my hundreds now because, yeah. So, and then 8 times 6 is 48. Add 4 more, 48, 49, 51, 52. And so now I have this large number, but now I have to add them together. That's the last step. And now because I've kept everything nice and neat, all my columns are correct. So you should get this answer, 53,192. Cool. All right, if I got that wrong, tell me, but I think I got that right. You can just plug it in your calculator to double check me. All right, so let's talk about converting. Well, the very first thing that we are going to convert is converting into a fraction, and I don't want us to use calculators because it's easier than you think. All right, so one thing to know, when you're converting into a fraction, you're always going to convert out of 100. Always out of 100%. So think like a dollar. I have 100% of a dollar. I have 100 pennies, right? So 30%, if I have, say, 50 cents, I have half of a dollar, 50% of a dollar. It's the same as 50 over 100. So for 30%, it's going to be 30 over 100. Okay, I have 30% of a dollar, which is 30 over 100. Well, I can simplify this. Please always remember to simplify. look at these zeros. If I were to divide by 10 on both sides, I would end up with 3/10. Okay, this is our simplified fraction. 30% is the same as 3/10. Now let's look at a decimal. A decimal, think again, money. I have 45 cents out of $1. I have 45 pennies out of 100 pennies. Okay, so 40.45 is the same as 45 out of 100. But now we need to simplify. And I know a lot of you struggle with figuring out, okay, well, what am I going to divide each of these by? Well, I look at my numbers here and I go, either I can divide by a 0, a 10. No, because that doesn't work with the 5. But I can divide by 5 because zeros usually will divide by 5 somehow. So let's divide our top and bottom by 5. Divide by 5. And I'm going to get 9/20. This is our fraction, okay? I'm going to try to give you nice, easy ones, but even still, you might get something like 0.37, okay? 0.37 is the same as 37/100. Oh, we can't simplify that, but you know what? That's the fraction, and that's okay. All right. Let me see. What else? I think I missed something on the previous one. No, we're not there yet. Okay. Let's do a refresh of our improper fractions and our mixed numbers. All right, remember that little trick I taught you guys. To convert this into an improper fraction right here, we are going to do our multiply and then add. Okay, so multiply, add. So if I multiply 3 times 4, I'm going to get 12, and then I add 2 more. I'm going to go multiply times, add 2 more. I'm going to get 14/3, right? Super simple. Now, you could break this apart and make 4 whole things, okay? 4 whole things is the same as 12/3, okay? So 4 is the same as 12/3. If I did 12 divided by 3, I would get 4, right? And then I could add the 2/3, which gets me to 14/3. Okay, so there's a couple different ways you can go about doing this. I tend to like our little tricky trick. And I'll draw a little like that, right? Multiply, and then, oops, that's not a very good add. Multiply, and then add. Okay, now on 8/3, we don't have that luxury, and we're going to convert it back to a mixed number. Well, I'm going to do some long division here, y'all. 8 divided by 3. 3 goes into 8 how many times? Well, the most it will go in there is twice. So then what you do is you do 2 times 3. I'm going to get 6. I'm going to subtract because I have 2 left over. Okay, so I have a remainder of 2. Well, I know I have 2 whole, and then I have 2/3 left over. Okay, remember, you're always going to want to keep your denominator the same. All right, so this is going to be your denominator. This is your whole. This is your numerator. All right, if you need to write yourself a little key for notes, let's do it right now. This is your whole. I'm going to write teeny tiny. This is your numerator. This is your denominator. I'll just put denom. Okay. All right, looking at negative 2 5/7. I don't like the negative, but I'll show you how to do it anyway. It's going to work whether you have a negative or positive. When you split this apart, you're going to split your 2 and your 5/7 apart, okay? You're going to have -2/1 plus -5/7. Okay, we're adding and subtracting here, and since we've split these apart, we still can take that negative with the 5/7. Okay, but you'll notice now our denominators are not the same. So we have to do a little tweaking to that. Remember when we did the converting, now I have to look at my opposite denominator and multiply it by itself over itself. Okay, so let's do a little converting right here just for the negative 2 over 1. I'm going to do it over here. Negative 2 over 1 times 7 over 7 is the same as, when you multiply across, 7 on the bottom, negative 14 on top. Okay, so this was our little convert piece that we had to do before we can do this. Now we have negative 14 sevenths plus negative 5 sevenths. Now remember, adding negatives, negative 14 plus negative 5, you're going to get a bigger negative. So that will get you to equal negative 19 over 7. Okay, you'll notice we talked about this before in class, or we may have, where I like to keep my negative in my numerator for multiple reasons, but it's just a good habit to do right now. Okay. Here's our answer for that. All right, now let's convert 27 fourths back into our fraction. Let's see here. So again, I'm going to do long division. You could also do, whoa, I lost my pen. Where did it go? There it is. Sorry about that. You could also break this up into 2 different pieces. All right, so I know that 4 goes into 27 6 times. 6 times 4 is 24, right? So I could do 24 fourths plus what's left over. 4, 5, 6, 27, 3 fourths. Well, 24 fourths is the same as 6, and then I'm left with 3 fourths, okay? Give me just 1 second here. All right. I don't want to start this video over again, so hold on just a second. I'm just texting my son who just tried to call me. So, all right. So now let's do converting into a decimal. It says no calculator, but I'm okay if you use a calculator on this one. Okay. If you don't know your, decimals already for a half. Okay. So a half is the same as 0.5. So if you put this in your calculator, it's 1 divided by 2. Okay? Now, same thing. This is kind of a nice thing to know. 1 divided by 2 or half is 0.5 or 50% or 50 cents of a dollar. Okay? If you look at 1/4, you will get 0.25. This is another good one to know. See if I'll do it. If you do 1/5, it's equal to 0.20. Okay. Let me think of another one. If you do 3/4, that is 0.75. And the other one I can think of is 1/10, which is the same as 0.10. Okay. So those are just some very basic decimals, fractions to decimals that are good for you to memorize if you don't already know them. All right, now looking at a percent, this is a little tricky trick, I know. Percents have these things that look like that, right? It's kind of a little hint. Oh, there's 2 zeros in there. But right now, my decimal for a whole number is right here, correct? So what you're going to do is you're actually going to be moving your decimal over 2 zeros. 1, 2. 2 spaces. So this is the same as 0.36. All right. Let's do another example. Let's say I had 47%. Same thing as move it over to 0.47. Looky there. Pretty simple, right? You don't need a calculator for that. All right, so if you need to write yourself a note, move to the left 2 spaces. Okay? Now, as for converting into a decimal from a fraction, sometimes you just need your calculator. So I'm going to go 4 divided by 25, and that is going to equal to 0.1 0.16. Now, one thing to note, make sure that you are doing your top number in your calculator first. So 4 goes in first, followed by the divided by sign and the 25. Okay, we're working our way from this top down. All right, pretty simple. All right, now let's move on to converting into a percentage. Again, not using the calculator. You can do this when it's already a decimal into a percentage, because what do we know? We're going to move the decimal the opposite direction now, 2 spaces to the right. Okay, so if this says 45 or 0.456, I already know, see my brain is already trying to do it, that this is the same as 45.6%. All right, so 1.6, well, there's no decimal or there's no space, so I have to create one, right? Which means I need to add a 0. This is the same as 160%. All right, now, like we talked on the last slide, some fractions you just don't know what the decimals are automatically. So if you plug 2 divided by 7 into your calculator, you're going to get a decimal. What do you get? Hopefully, if you do it, you get 0.2857. Well, we already know we have to move our decimal 2 spaces over, so this is the same as 28.57%. Cool beans, right? Pretty simple on this one. This one's like the easiest, I feel like. Converting percents to fractions and converting percents to decimals and decimals to percents is like no-brainer easy. You got this. All right, last slide here. This one is important because you need to be able to compare values. And sometimes we give you fractions that are improper fractions, right? Or sometimes we give you percents in our fractions or decimals in a percent. And so it's easy for our brains to get mixed up if we're not paying attention to what we're actually looking at and we're not converting it to the same format, okay? So in this first example, 2/5, 3/7. Which one's bigger? Do we know? Just by looking at, I don't know which one's going to be bigger. Okay, now before we even go there, I want to make sure we understand what does that mean, right? Well, this first symbol, you guys remember the alligators, right? Or Cookie Monster, whatever is the alligator's hungrier, okay? So it's going to open its mouth towards the bigger number. If we're going to be using language though, let's make sure that we know what these symbols mean and are. So this is the same as less than. Okay, and I know that because I'm reading from left to right. So I could say, for example, 1, here's an example, 1 is less than 3. All right, so sometimes when you're looking at that, make sure you're talking it through. Sometimes it took me forever to figure this out, believe it or not. All right, here's the other one, greater than. You need to say this to yourself, say it to yourself. So 20 is greater than 0. All right, and then we know what equal to is, right? Equals means 5 is equal to 5. They are going to be the same. Now, you might sometimes see something where you have a line underneath, okay? When you see a line, it means also equal to. So, for example, and you don't need to write this down if you feel like you know it, but let's say we have greater than or equal to. Well, is 5 is greater than equal to 5? Is it? Yes, it's true. Okay. 5 is also greater than or equal to 3. Okay. 5 is also greater than or equal to -20. Okay. All of those are true. All right. You could say 3 is less than or equal to 3. Is that true? Yes, it's true. 3 is also less than or equal to 100. Okay, so make sure you're paying attention to this little piece of the sign when necessary. Okay, so for now though, let's just focus on less than, greater than, or equal to. But the question is how are we going to get 2/5 and 3/7? How are we going to compare those? Well, some of you may think, oh, well, let's put them into the same denominator so we can compare those. I say, let's go easier. Use your calculator. So put a little, I don't know what you got to do, like a little star. Use calculator. Make it easier on yourself, okay? Put 2/5 in. What do you got? Well, 2/5 is the same as 0.4, okay? And 3/7 is the same as 0.429. Ooh, which one is greater than and which one is less than? Well, 0.4, they both have 0.4, right? But as soon as you start adding more decimals and more numbers after that first tenth, that means you have more than. So in this instance, 0.429 is greater than 0.4, which means that 3/7 is slightly greater than 2/5. Okay? All right, so here we have an example of a mixed number. Let's convert it. Okay, let's do our little tricky trick. 2 times 3 is 6, plus 1 is 7. So now I actually am comparing 7/3 and 9/4. Okay, now put those into your calculator. All right, so 7 divided by 3, you're going to get a number something like this, 2.33. And when I put a line over the top of the last number, it means that number goes forever. So 2.33333333. And it keeps on going, okay? And then 9 divided by 4 is the same as 2.25. So which number is greater? If you said this number, you would be correct, which means that this number is bigger than 9/4. 2 1/3 is bigger than 9/4, okay? You can't just look at it and know for sure what it is. All right, so what do you think we have to do for comparing 55% and 6/13? Well, if you said we have to move the decimals over, Mrs. Baxter, you would be correct. So let's do a little converting. All right, so 55% is the same as, I'm going to move my decimals over, is the same as 0.55. But now let's put 6/13 into our calculator. If you do that, you should get 0.462. Well, 0.55 is bigger than 0.462. Okay, so 55% is greater than 6/13. All right, last but certainly not least, what's our gut instinct saying about these two? Are they the same? Is one bigger? 35% looks bigger than 0.35, right? No. We need to convert them both to the same amount. So what is 35%? I'm going to take this and I'm going to go 1, 2, look at that, 0.35 and 0.35. We have a lovely equal sign. These are both the exact same thing. Okay, so that is pretty much everything in a nutshell. The last piece there is the biggest part of it, knowing can you compare those different values with each other and do the converting, okay? So go ahead, start on the homework. If you have any questions at all, please let me know. All right, good job.